All right, so first part of your daily cue, you were asked to give me the general form of the equation. The general form of the equation is just this guy. It's a first order reaction. So there's the first thing you should have written. The second part says, what is the rate constant K? Again, you're going to set the slope equal to negative K. Cancel out the -1. Good so far? Okay. Part C says, what is the concentration of A at 45 seconds? So next thing I'm going to do is I'm going to realize 45 seconds is time. Time is always on the X. I'm going to plug in 45 for T. And Y is the thing I'm going to solve for. Do we all understand that this is scientific notation? So we're okay if I write that? Okay. When you did this, what did we get for Y? Big negative number. -107 is the one I saw?
Yeah.
Is that about right?
Yeah.
107 point what?
8334.
Thank you. All right, next thing to do is to realize that Y does not directly equal the concentration at that time point. It equals the natural log of that concentration. So like we just did, you're going to manipulate by doing that E. Which I'm told is a very, very small number. I saw 1.47 times 10 to the negative 46th? 47th, okay. 1.47 times 10 to the negative 47th. And again, I gave you no context, right? You didn't get to see any data from this particular type of a reaction. So this number may not make any sense to you, but you have no idea what information you were given to work with at the beginning. I just gave you the overall graph relationship, right? With Excel, the practice problems we've done so far, you at least have a table of data to draw from where you can then look at that data and say, well, if the time is somewhere between these two time points that I graphed, then the concentration should be somewhere along my graph lines, right? You can actually see visually whether or not your data will make sense or not when you look at our Excel data. Who has a question? No. Okay. All right. Now let's look at a second order reaction. So last week when we were practicing, we did graph some second order data. And it was of like concentrations of NO2, I believe. Here we are. So last week we saw that the natural log graph was close, but the second order data was perfect, I believe. So we're going to use this to interpret a second order reaction. So there's my reaction. I'm going to ask a few questions. The first is going to be, what is the equation? The second is going to be, what is the rate constant? Third is going to be, what is the initial concentration? And the last is going to be, what is the concentration at, I don't remember if our time was in, it was in seconds in this one, at 100 seconds. Okay, so for part A, what is the equation of the integrated rate order? You have that up on the board. It's a second order reaction, so it's going to be this one. So, overlaying these two reactions, part B says, what is K? So what is my K value? Well, so in this case, a second order reaction has a positive slope, so I can just plug K into whatever the slope is. I don't have to manipulate it. Remember that first and zero order reactions have negative slopes, so yeah, you do have to plug the negative in and then cancel them out. Part C says, what is initial A? So how do I do that? Do you remember from previous? I'm going to set these two equal to each other. The y-intercept and 1 over A naught. Am I done?
No.
What do I got to do? I gotta get this on top of the fraction, right? So I'm going to multiply both sides by the concentration. Am I done?
No.
No. More algebra. Calculator. Give or take. Oh, wait. 1 over 100, is that 0.01?
Yeah.
Oops. So the initial concentration of A should have been about 0.01 molar, assuming we're using a set of data, which I'm not going to go back and look at the concentration of NO2 and see if it was in moles or if it was in pressure, but whatever your original concentration units are that you graphed are the ones that you should be using for this. I'm pretty sure my practice data was molarity, but it could be pressure units, could be molality, could be any concentration unit that you graphed. All right, that was part C. So part D says, what is the concentration of A at 100 seconds, which is what T is going to be. So in our equation, T is equal to X. So we're going to plug in 100 for X, and we're going to solve for 1 over AT. Why are we not going to solve for 1 over A naught in this particular case? Because that's actually something that was given up here, right? So we're going to do the y equals equation. What's up, Molly?
I didn't know if it was going to be 100 seconds for all,
Say again?
like all the example problems. Is it always going to be 100 seconds?
No. I don't remember what the example problem said. But that's a good question. I'm pretty sure the example problems want you to solve for K in the initial concentration. That's all I remember. We'll have to look at the document. It's in the original document where all the data was.
Okay.
You have to look at the first page It tells you all of the different steps. All right, so then in solving for this, what do we get?
154.143.
Whoa, say it again?
154.143.
Someone else in the room should be doing it too. Should be multiple people. You get the same thing? Okay. All right, are we done? No. We need to plug in what we know y to be. Solve for A. What'd you get for A? Yeah. In these equations, I will remind you from our talks last week, the t's mean at any time point. So for our specific manipulation just now, t was 100 seconds. So you could write the natural log, or I'm sorry, 1 over a at 100 seconds if you wanted. Okay, they do not actually insert themselves into our math unless you're plugging them in for that time point, right? The 0 that comes after the a is called a naught, and it means initial every time. Okay, do you have a question? Thought I saw a hand. Okay, all right, so you're going to get your data out next. That's not it. Oh my gosh. Okay. Your data from last week on the integrated rate laws. On the very first page, it tells you to do a couple of things. The first 3 or 4, the first 3 was to get the graph, get the line, figure out if it's first, second, or 0 order. Number 4 says to determine the rate constant for the decomposition using the lines equation. So that means determine K using your graphed equation. The second is it 0, 1, or 2 order? The next is to predict the concentration after double the latest time point given. So whatever your last time point is on the data set. So let's look at example 1. On example 1, the last time point you were given was 24. So you were supposed to determine the concentration at double that, which is 48 hours, right? So you're going to plug in T for 48 hours for that particular problem and solve for A. So you're going to want a sheet of paper for you to write on. You're going to go through the example problems, and you're going to do them one at a time. So for the first one, you're going to write what the equation is from your Excel file. The next thing you're going to do is tell me if it's 0, 1, or 2 order. Then you're going to determine the K and your concentration at the last time point. The last thing you have to do is the half-life. What I'm going to ask you to do for number 7, the half-life is determined using K and the equations from lecture. There were 2 equations for half-life. One was for a first order, one was for a second order. If your graphs are 0 order, you cannot determine the half-life using this type of a method. Okay? You would have to just do first and second order graphs for the half-life equations. I'll put them up there here in a second, but for now, get started. Did you get close to 1? Like that? That is the closest to 1 you're going to make. And that's good. And then the same thing here. That's as close to 1 as you're going to make. Okay? That's a good question. So some of us, if you did not get exactly 1 on your Excel graph, that's okay. If you got something that's like 0.999, that's exactly the one you want to use. Okay? Well, so my data was designed to teach. So some of them are going to be perfect and some of them are not. Yes. Sir?
Would you have to convert hours to seconds, or can you just...
No. Whatever time they gave you, keep it in that time. Yeah. It's a good question. You don't have to convert any of your data.
We need to do this for all of the Excel graphs, too?
Yeah, for all 4 that you did for this. So there were 4 for this, remember, for the Excel data? Do this stuff for all 4. And you can go through and you number them 1 through 7. 1, 2, and 3 you've already done, so you can just write done in Excel, done in Excel, done in Excel. Yes,
Okay.
yes, yes.
1, 2, and 3 is something like
Are we talking for just 60 seconds? Because
Well, you need to tell me, no, you have to do 4 through 7. Determine the rate constant, right?
Okay.
Tell me what the equation is. Then you're going to describe if it's 0, 1, or 2. So you just, for number 5, you'd write 0 order, first order, second order. Does that make sense?
Okay.
You can go through all 4 problems and you can write 1 through 7, and then for like numbers 1, 2, and 3, write done in Excel. Does that make sense?
Yeah.
Because I think number 1 says manipulate the data, so you can write done in Excel. For number 2, graph the concentration, done in Excel. For number 3, determine which graph has a straight line, done in Excel. And then you can give the graphed line equation for number 3. For number 4, then it says determine the rate constant. So you would do the what is K. For number 5, it says describe if it's 0, first, or second. So all you have to write for number 5 is 0 order, first order, second order. Then for numbers 6 and 7, you're doing math. Number 6 says to determine what the concentration is at double the last time point. And number 7 says to do the half-life.
You said, the equation from the last and the four, right?
You also have to use it for number 4.
Well,
Number 3 is still like, what is the graph?
that's
Yeah.
an Excel, right? So
But number 4, yes, you have to use the slope from the graph.
So, this is my first set of data, so
So it's the first order, right? So you're
Yeah.
using that one.
So what would I write? I would write the line equals the.
Oh, and then you would tell me that K is equal to 0.15.
Okay.
Solve for K in number 4.
Okay, thank you.
Yeah, that's the half-life equation. Do you have anything? Do you have anything?
Yeah.
No, that's what you're solving for. T1 half is like the whole
Oh.
variable.
So that's just it.
Right.
So we double. Sorry, we double.
Double the last time, some of each one.
So, are you finding K for the one that works?
For the one that's the best, yes.
So if
You
it's,
only find K for the one that has the best fit.
if it's second order, is it just that?
So the second order one is positive slope. Good question.
Which one, this side?
Yes, please remember, you're only using the equation that makes sense. You're not doing all 3 equations.
We were looking for a
Which one?
for like the number 6 and the 0. So like I'm just plugging in the find out what that is.
Right.
At 48 hours. So then we look at
What's the equation?
Is
Hey, which one are you doing?
easy to consider the number 6. So first
Okay, wait, but that reaction is 0 order. Your 0 order graph is not the one that has the r squared of 1. Go down. What other graphs do you have? Yeah, so it's a first order reaction. You only do it for the order that it is. Yeah.
only the
So like, why would you do it for 0 order if the 0 order data doesn't fit? You only do it for the one that fits, guys. Guys, you're only doing these problems for the graph that fits. So you did 3 graphs for each problem, but you only use one of the graph's data to do this math. The rest of the graphs don't count. Right? They were our practice that we were trying to figure out what the order is. So you ignore the other 2 graphs that do not have the r-squared value that you were looking for. Make sense? That's how you also determine 0 first or second order for number 5. You use the graphs and say, oh, it's a first order reaction. So then once you know it's a first order reaction because the r-squared value fit, that's the equation you're going to use to interpret everything else. And so, that's it. Okay? Okay? This is the right one.
That's the, that,
Oh, okay.
and then you're trying to get only that one.
Yeah.
So this is for problem 1, right? These 3, or?
So then what is A? 48. So you're going to do the y equals, so where's the y equals? So you're going to plug in 48 for x. Solve for y.
That's easy for those, right?
Okay, so.
If you're doing second order, it's equal to
48
1. If you're doing first
Okay.
order, it's opposite.
48. Good.
Zero.
So then,
Wait, where's your equation?
for zero,
Okay, but you plug it in.
For zero.
Because like y equals, so where's your y equals?
Second option.
second is equals, first is opposite.
X, right? Okay, so this is the one we should be using, and you know k is this because of
Zero
that.
is
But
opposite.
don't forget,
First is
that when you get to number
opposite.
6, you're doing y equals negative,
So I just need a negative. Which is what you wrote down before.
and then x is gonna be your 48. You just read the
No,
negative
we
sign.
already made it.
So this is what y will be.
So even though it's
Times
positive here,
the 48.
Yeah, because we made it positive,
Double.
forced it to be positive, right?
Final.
yeah,
Because what we did is we said, given this, k, t,
Plus the initial, which,
so does, do you know what I'm saying?
doesn't it always have to be positive, like that's what we do?
K will always end up positive, yes.
Okay, and
We
then,
will always force k to be positive,
so that's.
but our
what-
slope
that's
should be
what I want.
negative. So when our slope is negative, the equation. So our natural log of a will always equal negative k times t plus the natural log of a. So in other words, like look at the equations up there, right? Zero and first order reactions will always have negative slopes, which is why in the equations there's a negative in front of k to get rid of the negative sign on the slope. You still have to use the original equation though, right? So for instance, this one you have y equals negative 0.1155x. You can't just get rid of the negative when you're trying to solve for something using that equation. Okay? So now for this one, you were trying to figure out the y when x is 48 for number 6. So you're just going to plug it in. You're going to plug the 48. You're going to plug in the x for 48 and solve for y. Then your y is going to equal the natural log of pi at a time point. That part? Where we like switch it around at the end.
basically it's going to be this,
But I'm
and then
guessing
plug it into the,
Correct.
okay.
And solve for a.
Okay, thanks.
that's what she wants to do.
What was
You know what I'm
plugging
saying?
in
You would plug in 0.
Just zero?
You would
Because
say
that's
the
what-
natural log of the
That's
concentration
not
of A at 0 is 0. I
Okay,
mean,
okay, so it's just.
so it would just end up being 1. The concentration of A, once you take e to the 0, is going to be 1, right? Any number to the 0 is 1.
For number 6, which is the concentration of the double, what I do, is it log or just like the end?
Yeah,
Which one
because
first?
it's allowed to zero.
So then you use the log of
I just
double.
don't, okay, but then I double it and do like negative 5, like something.
Oh, no, you double the time point.
For number 1.
You double the time point.
0.8.
You make that 48, plug it in for x.
Okay.
Does that make sense?
Yeah, and then for the half-life,
And I
do I
believe
make
we
it
still,
AO?
we still take the, like the,
So is it a first or a second order?
I didn't get that.
Okay. Then the first order equation, isn't it just
I got a negative.
0.693 over k? Look at those equations from your notes, but you're gonna wanna use the half-life equations from your notes. Yes.
Is it okay if I get rid
Yeah,
of
you
these?
Since you already submitted it, no, you can move on. Yeah. That's a good question. I did have someone ask if you could get rid of the graphs that you've already, that are not gonna fit. Since you already submitted it, like if you already submitted your Excel file, you do not have to keep any of the graphs you don't need anymore. So you can delete the 2 that don't make sense for each problem. If that helps clear it up for you.
Also, for, the number 6 is, stick concentration, what unit would that be in?
Concentration, what does it give you? It was given to you
Yeah,
in
and-
molar, right?
First, yeah, so what I'm
So
saying,
molarity, yeah, capital M.
yeah, and then secondly, how do you determine
I
what
have the
and
equations for that.
How do you do what?
the half-life?
Do you have those equations from lecture?
Oh,
Because there's, I was gonna put those on the board. Give me 1 second.
Well, we only got 5 minutes.
You're fine. I'll put your half-life stuff on the board. Boys and girls, tomorrow in class we'll spend some time working on these too, just to make sure you know what you're doing. If you feel good working forward, please do. Who has their notes open for the half-life equations? I know the first one. I just don't know the second one. Is that it? Yeah. Okay, thank you. Those are your half-life equations for a first order and a second order. There's a zero order, you don't do a first order, you don't do a half-life. We just did e to the negative 5.5. Yeah, that should be good. And then you're gonna do and then you're gonna do this one. So you're gonna do 1/2. So T1/2 will just equal 1 over whatever K times the concentration initial is. You do have to figure out what the initial. No, it's not homework. No, it's not homework.
Is that a zero or is that?
I think it's two.
You got y, this is y, right? And 1 over a equals that. Get it straight. Good. You're good. And now that you have initial a, you can do this one. Because for number 7, you calculate initial a. No. You put this into a. It's the same amount, not a. Not a at a time b. T1/2 is the whole thing.
And it would be this K, right?
Correct.
I think you purify one.
This morning I wanted to share.
Times the initial concentration.
I'm like, what do you think I'm making wrong? And I rounded to, you think I'm making that okay? I didn't, as far as what I thought.
Doing fine.
Yeah, no, I mean,
You're interpreting the math as the fun part.
Yeah, I think this morning.
So far, yes.
Anyway. Well, I was thinking about.
The T1/2 that most of us are getting is that it's 6 hours. So.
What do you think?
For number 1, what's the half-life that you've gotten? I've seen 6 hours. Is that about right? For some of us who've done it so far, it should be a 6 for T1/2.
I really want to buy that.